Eric Burgess here, and we've been given the following question. So this looks pretty gross. We notice that the bases are the same for these, but the powers are different. But we also notice that this power is 2 times this power. Now you might also, just to bring it up, you might also see fractions where this is like 1/2 or like 1/3 and this is 2/3. This is also just 2 times whatever this is, right? Because 2 times 1 is just 2. So you get 2/3. So the technique we're going to talk about here will work for all the questions that involve things that, look kind of gross at first. Now, if you're super familiar with factoring, you don't actually need to do this technique, but I think it's a good one to learn. You're definitely going to use it at some point to help a problem look a little easier. And it's called a U substitution. So working with this isn't that great, but we could say, well, what if this whole thing, what if we took this, because we've made the astute observation that this thing is just this thing squared, right? Because all they have is they've doubled the power. So whatever this is just it squared. So we say, well, what if we let this whole gross thing become just a variable? So we say that let u, and now u is a very, very commonly picked variable. You don't have to pick u though. You can pick anything. You can pick q, r. You just can't pick x because we're already using x. So, but u, they call it a u sub because you usually pick u. You'll see in calculus as you get to it in the next classes that it's called a u sub, like officially, like that's the term. So we're going to take u and then we're going to let that equal this whole thing right here. X minus 4 all squared. Don't forget to include the power. I see people leave out the power and they get confused. No, we want to include the power because that's part of what makes it confusing. So we say, okay, well, we've noticed that so now we can replace this thing up here with u. But this thing over here, well, that's like u squared because check this out. If we were to square both sides of u, we'd get minus 4 squared, which is equal to x minus 4 to the 4th, which is exactly what this is. So by doing this one u sub, we have a way now of replacing both terms. So if we look at this, if we replace them, we're going to get 8u squared minus 10u equals -3. So this is what we can do. Now, I did the u sub first. You can move the 3 over and then do the u sub. It doesn't matter. So now this is called the u sub. So I want to point out something. I'm going to highlight, we're going to call this our substitution rule up here. This rule describes how to take an x. We see we put in an x to this expression, and it describes how to get to its equivalent u. So when we solve this equation, we're solving it in terms of u. It's not, x wouldn't do the same thing, but we can use this highlighted rule to go back and forth between u and x. And we're going to come back to this. But I just want to make it clear that we are now in what we would call the u domain. We've taken x, we've done some stuff to it. We've subtracted 4 and then we square it, right? So we're doing things to x, and this is what u is. So this is the rule on how to go from an x to a u. So okay, let's go ahead, let's factor this. So we're going to get, well, let's get it in to a form that's a little nicer. Do 10u. And then if we add 3 to both sides, we'll get rid of that -3 on that side. So from here, we can factor. So we're going to have 8. And I notice we're going to need a 10 here. And I'm just going to go ahead and hazard a guess at 2 and 4. So I'm going to put 2 here, and that's a u. And then we're going to have a 4, and then a u. This has to equal 0. We need a positive here and a negative here. So our inner signs have to be negative times a negative because those will multiply to give a positive. And then we say, okay, well, 3 and 1 are the only combinations of that give 3. So we have to choose where we're going to put this 3. Well, if we put the 3 here, it's going to be multiplied by the 4. That's 12, so that's too big. So we're going to put the 3 right here. This will be multiplied by the 2. And then we'll put the 1 right here. And let's try this out. So 2 times 3 Well, that's 6, and 4 times 1, that's 4, and they're both negative. That gives us negative 10. So we have successfully factored it. You can use whatever factor method you're used to using, or you could use the quadratic equation. That'll work every time. So let's go ahead. Let's do this thing. So we'll use the zero factor property and set each of them individually equal to 0. And then we'll solve this. So we're going to add 1 and then divide by 2. So we'll get 1/2 on this side. And on this side, we're going to add 3 and divide by 4. So we're going to get 3/4 on this side. Now these are answers in terms of u. And we don't want answers in terms of u because our first equation, we plugged in x's. So we're going to use our rule that we talked about. We're going to take our rule, u equals x minus 4 squared. We're going to solve for x. Solve for x. And what this will do is it will tell us how to plug in a u, and it will convert it to x for us. Because right now we plug in x's and it gives us u's. So we want to go the other way. So to do that, we need to solve for x. So to do that, we're going to take the square root of both sides. So we take the square root of u. And when we do that, we have the plus and minus. And we take the square root of this side and we get x minus 4. And you might be going, why plus and minus? Well, the reason is we don't know which root gave us u. So let's take, for example, 4. We take the square root and we get plus or minus 2. Why? Because, well, if we took negative 2 and squared it, that would give us 4. And if we took positive 2 and squared it, that would give us 4. So we're not sure which gives us 4. So we have to put plus or minus. Now this is our rule, but you might also be saying, well, if we had to put a plus and minus in front of the u, why don't we need to put a plus and minus in front of this when we take the square root? And the answer is technically you do, but it winds up not mattering. And let me just show you. I think it's easier if I just show you. So let's say that we took it. So this is like the plus version of it, right? We multiplied by a positive. Well, there's a second version where we multiply it by a negative. And if we do that, it's going to be minus x plus 4. And now if we go ahead and solve for our rule, we're going to get plus or minus the square root of u minus 4 equals negative x. When we divide by a negative, we're going to get plus and minus u. Technically, these like swap, but you'd get the exact same thing, so it doesn't change. And then we get plus 4 equals x when we divide the negative out. And we get the exact same rule. And so it actually won't matter. And part of it is the fact that this was squared, and we have an expression and we're moving pieces over, and that's what made this kind of work the way it did. So, but just to show you, you actually get the same rule. So now we can plug our u values in. So for u is 1/2, we could plug that right in. And we'll take the positive version first. So we're going to go ahead and take the square root, second square root, 1/2. And we get this. And so there's going to be one where we have plus 4. And we get that. So there'll be an x that's equal to 4.707 approximately. And there'll be one where we have 4 minus this number up here. And we get x is equal to 3.29. I'm going to round 3. And now we got to do the same thing for 3/4. So we're going to have a square root of, and what do we got here? We got 3/4. So we're going to do 3 divided by 4. And we get this. So 1x is going to be 4.866. And the other x is going to be 4 minus this. So we're going to do 4 minus this thing. And we get 3.13. Oh, we'll go to 3 places. We'll be consistent. Okay, so these are all our x values that can make the equation true. And we actually know that they'll all work because we have no square roots and radicals. So they'll all actually be valid. But I want to show you, just to sort of build your faith, I guess, that this indeed is true. So let's go ahead. Let's just check. We'll just check the first two. So we'll do x times 8 times x. So our first x was 4.707. 4.707 minus 4. And this was all raised to the fourth. Minus 10. And this was 4.707 minus 4 quantity squared. And we should expect to get a number extremely close to -3. I rounded here, so it might not be exact. But let's do this. And you see we get a number super duper close to -3. Now let's go ahead and do the same thing, but this time let's just change out the number for our second x, which was 3.293. So we're going to come in, and this was the negative version, 3.293. Maybe we'll check all four. It would be easy because we just have to replace it. 293. We do it, and again we get a number super close to -3. So this plus minus, you would have missed a solution if you didn't do this. So very, very important thing to keep track of. Now let's come up and let's go ahead and check the others. What the heck, we'll do it for fun. Easy peasy. So we're going to come in, we'll do 4.866. And we'll come on over and we'll do 4.866. And we do it, and look at that. That's like smoking right there. The -3 out the wazoo. And then our last one, the negative version of that, was 3.134. And we'll come on over and type that in, 3.134. And we get, again, extremely close. So these are all going to be our solutions. And the way we would write this, we'd say that x is an element of the set. And then we'd put 4.707, 3.293, 4.866, and 3.134. 3.134. And we'd close out the set if I can draw a bracket, and we're gonna go ahead and just box this. We'd say here are our answers. We got them all, and so we've covered a couple of pretty important principles here. We covered the idea of a u sub. We covered the idea of converting back to x, and we also covered the idea of the importance of the plus minus and why it matters in this case, because we would have totally missed solutions if we didn't do that, and also why it didn't matter when we did this one. It turned out that you actually get the exact same rule if you take the negative version of this side, so it didn't matter. And we can actually chalk this up to symmetry due to the square here. If you were to graph this, it would actually be a symmetrical curve, whereas with this one, this was not a symmetrical curve, it was a line. So when you took the square root of this guy plus minus, there was genuine uniqueness on one side of the graph. But at this point in your class, I don't think you've gotten into graphs and stuff yet. So some of these rules will make more sense as you get further along, because you'll begin to learn extra insights about what some of these things can mean. If you have any questions about this, let me know, subscribe, and we will catch you in the next problem.